Hello, my name is James Binion, and I've put this video together to show how I'm casting the submarine Dolphins in HY80 steel. Start off with a digital model, and that digital model is then going to be sent to a 3D printer. This is the 3D printer that I use to print the Dolphins. The software for the printer takes the CAD model and slices it into a whole bunch of thin slices and then exposes it onto this plate using UV light to cure the resin only in the spots where it's needed. This specific resin is used in lost wax casting, or in this case lost plastic casting, where I'm going to take these plastic parts and I'm going to enclose them in a ceramic material called investment. And once that's cured, I'm going to burn it out, and it'll cleanly burn out and leave me with a cavity in the ceramic that the molten metal gets poured into. So these parts have been grown. They need to be rinsed off in isopropyl alcohol. Get rid of any excess resin that's still on the surface of the part. So it's a two-stage process where I rinse it first in some dirtier alcohol and then move it into some cleaner alcohol and get rid of all the uncured resin that's sitting on the part. After the parts are rinsed off, they're going to go through some further curing processes to make sure that all the resin is completely cured before I try and set it up to be cast. But right now I've got these nice plastic models of the Dolphin ready to go, and next step is to mount them in a flask to cast. So here they've been attached with wax to the casting button, and now they're sitting in a stainless steel flask, and that flask is going to hold the liquid ceramic material that I'm getting ready to pour on top of it. Here I'm mixing up the ceramic. You got to be pretty quick in doing this. You've only got a couple of minutes of time once the ceramic is mixed with the activating liquid before things start to solidify. So I've added the two together, and I'm going to give it a quick stir with a manual spatula, and that's helping me make sure that all that powder is wetted before I start going through the next step of the process, which is where I'm going to vacuum mix it. So the vacuum is going to help me make sure that there's no air left in the material, so that when it gets poured over the plastic patterns and the wax sprues, that it'll be nice and bubble free when I cast it. So I've hooked it up to a vacuum pump, and this little doodad allows me to continue to mix it while the air is being pulled out of the chamber. So I'm going to mix it here, make sure everything's all nice. The powder and the activating liquid are all nice and well mixed. And this is going to give me a really good bubble-free material and uniform ceramic. So I'll give it a few more turns here. Take the vacuum port off. Now I'm going to pour it into the flask. And now, because nothing is perfect, I'm going to vacuum it one more time to make sure that I've got all the bubbles that I can get off in the process. So I put this bell jar on top of the flask, and now I'm pulling all the air out of the bell jar, and it's kind of hard to see in the video, but it'll start bubbling as the vacuum level starts dropping inside of the bell jar. and it'll start actually boiling in there, and that's going to pull all of the residual air that's in that material out. And I just check my watch to make sure that I'm not running overtime here. And as soon as it's debubbled enough, give it a couple of quick bounces, make sure the bubbles break, and then I'm going to release the vacuum. And I'm going to take what's left in that jar and I'm going to pour it in there. This stuff won't really cause any bubble issues because it's just going to be sitting on the very top of the flask. So get all of that stuff in there. And then I'm going to clean off the top rim of the flask because it's easier to clean a little bit off at this point while it's liquid than once it hardens up. So I set it aside and let it sit for several hours. And then it goes into the kiln where all the wax and plastic is burned out to leave a hollow mold behind to pour the metal into. After it goes into the kiln and everything's all burnt out, I take it and I put it in my casting machine. This flask is about 1200 degrees Fahrenheit right now, so can't just reach in there with my fingers and grab it and put it in there. So a little fiddling around to make sure it's sitting nice and correctly in that machine. When I turn the machine on, the flask starts to spin. So this is a centrifugal casting machine. The flask is spinning at about 900 RPM. And now comes the fun part. Now in this case, the metal is a very high temperature material. The HY80 steel melts at somewhere close to 2600 Fahrenheit, between the upper end of 2500 and the upper end of 2600. It's all going to be liquid. So I've got to have something really hot to melt it. So I'm using a DC arc from a welding torch to melt this. So I'm striking the arc on the metal. There's an electrode in the bottom of the crucible where I'm melting this that's allowing me to make the connection between the torch and the metal. And it takes a few minutes for me to get all of it melted and get it all hot enough so that it's ready to pour into the mold. And unfortunately, you can't really see anything down there because the arc light is so bright. The arc is about 11,000 degrees Fahrenheit, so it makes fairly short work of melting the HY80 steel, but it still takes a few minutes to get it all to the point to where it's molten enough and get the crucible heated up well enough. And there's argon coming out of that torch, and it's keeping it from getting over-oxidized. You can see when the oxygen gets in there, it will get sparking as the steel tries to burn away. But the argon keeps the steel from being excessively oxidized during the melting process. Now I'm starting to wiggle the crucible because it's getting all nice and molten. And as soon as it looks like everything's moving around nice and everything is fluid, I'm going to tip it up and pour it into the casting machine. And now you can see that all that metal's down there in the mold, and you can kind of see how it's spinning away down there. And it's still spinning, and as you can see, the temperature's dropping. It's starting to get cooler as it spins. It's going to take about 10 or 15 minutes before that's going to be cool enough to do anything else with, but I'll take it out of the machine here in just a moment. So I've turned it off. You saw that it stopped spinning there. And you can see where a little bit of extra metal flew out along the top of the flask. There, that's that gray kind of spiral streak that's on top of the flask. and disconnect it from the machine, and I'm going to go set it down to cool. Okay, after waiting a while for it to cool, I need to break that ceramic out. So I've dunked the flask into water and I'm allowing it to cool. It's still pretty darn hot. This is like 15 minutes later and it's still really hot. That ceramic does not cool down very quickly. And it's pretty tough stuff. It's stuck in there really well, but you need this very strong high temperature ceramic to do materials like the HY80 steel or anything that's really super hot like this. Requires a pretty strong and tough ceramic material to allow you to cast it. So I'm breaking it up, and now it's fallen out of there, and now all I've got left is the flask with some residual material in there, and I'm going to break that out just a bit. And then I'll set it to the side. And there's the cast Dolphins. They've still got a lot of ceramic material stuck to them, so I'll try and break out what I can that's cracked from the process of me hammering on it. But I'm going to have to take it over to a water blast cabinet that's going to help me remove more of that investment off of the Dolphins. I'm going to give it another couple of whacks with the hammer just to help speed that up. So I'm hitting the central cast ring. I'm not hitting the Dolphins themselves. I'm hitting the ring that was formed by the sprue base. And as I do, that shock is transmitted to the ceramic and it breaks up. I wish it would all come off this way, but it's still got a fair amount of it that's stuck on there pretty well. So this is the water blast cabinet, and this is basically a pressure washer that's set up inside of an enclosed cabinet, and I'm using a 2000 PSI blast to remove that residual investment, or a lot of it, from the piece. And I have to have multiple layers of gloves on, because if I'm not careful and that water stream hits the glove, it just goes right through it. So multiple layers of gloves to keep from cutting my fingers up with that water blast. It's pretty strong. And this will remove a lot, but it won't remove all of the investment. Well, I'll still have to work on cleaning little bits of it off as I continue on with the process. But you can see there's the steel casting of the Dolphins. There's still a lot of work yet to clean it up, get it ready to go. There's a lot of crud on there where the metal and the mold came together and they form a really nasty skin on the surface of this casting. So after I've removed the investment from the piece, or most of it, I need to cut the Dolphins off of the central sprue ring. And so I'm using a little bandsaw here. And I've got this sped up quite a bit because you don't want to sit here and watch me just trim each individual piece off. So I'm doing a little fast forward here so you can get an idea of just what it takes. I've got to cut each individual sprue off, and HY80 is pretty tough stuff, so it takes a little bit of time to cut them. And so there are 6 dolphins ready for the next steps in finishing and cleaning them up. After they're cleaned up, and we solder the posts on the back of them and do the final finish, and then box them up and ship them off to the folks that order them. So thank you very much for watching, and I hope this answered the questions about how I make them.